Hi, this is Alex here again with another short tutorial video. In this tutorial video we will go over how to model using dialog boxes. In the previous video we went over how to model only using the table, and in the next video we're going to go over how to model only using the graphical area. To start off, we'll go up into the left hand corner and click on the new model button. We'll name our model and then we will click OK. The 7 things we need to determine when creating a new model are nodes, lines, supports, material, cross-section, loads, and then results. So to start off, we can go up under Insert and go to Model Data and then go to Nodes. Under this drop-down box, we can go to Dialog Box. Within this dialog box, we can set our first node to the origin, which is 0, 0, 0, so we'll click OK. As you can see, our first node was placed. We would like to place the next node 10 feet away from this node in the X direction, so we can go back up into Insert, go to Model Data, go to Nodes, and go to Dialog Box again. Then we can go to the coordinate X and input 10 feet. This will put a node in the positive X direction 10 feet away from our origin node. Now that we have our nodes, we would like to place a line in between these nodes. We can go back up into Insert, go to Model Data, and then we can go to Lines. As you can see, there's a lot of different lines we can select from. For now, we're going to use a polyline, and we're going to click on Dialog Box. Within this dialog box, we will select the nodes we would like to place the line in between. Within this list of nodes, we can either select our nodes graphically by clicking on them and then clicking OK in this box, or we can enter them manually. As you can see, our line was created between our two nodes after clicking OK. Now that we have our line and nodes, we would like to create a material. As you can see in our project navigator under materials, we already have a material set, but it's blue, so it's not assigned to any certain cross section or member. We will keep still A992 and move on to assigning a cross section. Instead of going up into Insert, Model Data, and going to cross section, we can just go into our project navigator and right click on cross section. We can click new cross section. A dialog box will pop up where we can input our own cross section properties and create our own cross section, or we can click on the button import from cross section library where predetermined cross sections are taken from standards. We're going to do this and we're going to use an I-beam. We're going to take an I-beam from the AISC 15, a W shape, and we're going to use a 30 by 326. We'll click OK. Now that our cross section is defined, you can see that it's blue because it doesn't have a member to it, and our material is now black because it is assigned to this 30 by 326 W shape. Now that our cross section is defined, we can assign it to a member. We can do this within the project navigator as well by going to the members folder and right clicking on members and going to new member. As you can see, we have a dialog box that pops up where we can assign our member to a line. We can go up here to line number and we can either type in line 1 or we can assign the line graphically by clicking on it and clicking OK within this box. Just briefly going over this dialog box, you can see you can select your member type within this drop down box up above the graphical display of the cross section. You can also rotate the cross section as well over here. And below we have our member start and member end cross section along with member hinges we can assign to the end of the member. For now we're going to keep the member start as W30 by 326 and we'll click OK. As you can see, the member has been assigned to our line and our cross section has been rendered. So now we can move on to creating Nodal Supports for this member. To do this, we could go up to Insert, Model Data, and go down to Nodal Supports and click on Dialog Box. Or I think it's easier to just use the project navigator, and as you can see, all of that is organized within here. And you can just go to Nodal Supports, right click on Nodal Supports, and click New Nodal Support. Here, for our first nodal support, for our first node, we'll unlock the rotation about the Z-axis and we'll click OK. I forgot to assign the support to the node, so we'll go to Edit Nodal Support and we'll select our first nodal support, click OK. The dialog box will appear back up, and up here is where you will assign the support to the node, and we'll input 1 for node 1 and click OK. As you can see, the support was assigned to the first node. Now we want to create another nodal support, so we'll click New Nodal Support. And for this node, we want to unlock the rotation about the Z and lock the rotation about the X, so the member doesn't spin about its own axis. And we want to unlock the movement along the global x-axis. We'll assign the support to node 2, and then we'll hit enter. Now you can see that our nodal supports have been assigned to both of our nodes. Now that our member is fully defined and supported, we can start assigning loads to it. Before we can assign a load, we'll have to create a load case. We can do this by going to our project navigator under load cases and combinations, and we can right click on load case and click new load case. You can see our load case window pops up, and it already created our first load case, and this one will be our dead load. We'll just name this one dead load and keep the self weight active, and then we'll click OK. Now that our load case has been created, we'll go down to the loads folder and we'll expand the dead load case. Here you can see all of the different loads you can apply to the member. For now, we're going to just apply a member load. So we're going to right click on member load and click new member load. As you can see, our new member load dialog box pops up, and we're going to keep our load type as a force, and we're going to use a uniform load distribution. For our load direction, we'll keep it as the global true member length and the Z direction. You can also have this be projected, and as you can see, choosing either projected or true member length changes the graphic down here, and that gives you a nice visual representation of what these each represent. For now, we're going to keep it as the true member length. Now we can go down to load parameters and input a load of -1 kip per feet. We'll click OK. Now we must assign this load to a member, and we want to assign it to our member 1. You can also do this again by clicking on select members, and you can select the member graphically if you'd like. We'll click OK. And now our load is assigned to our member, and you can see this within the graphical area. Now we only want to show the results for this load case, so we'll go up to this button right here called show results. We'll click OK and run our results. Now you can see our results are displayed, and our results tab has come up in our project navigator along with our panel. A future video will be dedicated on going over results more in depth and how to display different results along with colored cross sections and colored results. For now, we can also view the maximum moment by clicking on members and clicking on moment about the y-axis. As you can see, our maximum moment was 16.579 kip feet. So that concludes this short tutorial, and I hope this video was helpful in demonstrating how to model using only dialog boxes. In the next video, I'll go over how to model only using the graphical area. Thanks for watching.